Okay, I want to look at a thermochemistry problem today, and the question that we're going to be trying to answer is the following one. If we take 1.25 grams of ammonium nitrate and dissolve it in water to make 25.0 milliliters of solution, and the temperature changes, it decreases actually from 25.8 to 21.9, we want to calculate the value of delta H for this reaction, and we're given some information about the density of the solution and the heat capacity. So, or actually I should say the specific heat. The equation that we're dealing with is this one. Ammonium nitrate going from solid to aqueous. We're dissolving it in water. And what we want to remember, first we're going to calculate the amount of heat that's given off by this reaction for 1.25 grams dissolved to make 25 milliliters of solution. But we want to remember the temperature change that we're measuring, it's not on the ammonium nitrate. We can't measure the ammonium nitrate directly. We're measuring the 25 milliliters of water that it's being dissolved in. And that means two things. First, it means that we're not measuring the reaction directly, but the surroundings. And it also means that the mass of the thing that's changing temperature is not the 1.25 grams, but the 25.0 milliliters of solution. So if we take the density as given in the problem to be 1.0 grams per milliliter, 25.0 milliliters times 1.0 grams per milliliter gives us a mass of 25 grams. So we're going to plug 25 grams in as our mass. 4.18 joules per gram degree Celsius is going to be our specific heat, and the delta T going from 25.8 to 21.9 is 3.9, but it's a decrease in temperature, so it's negative 3.9. If we look at that calculation, we see that the change in heat of the water that we're measuring is negative 410 joules. Now we want to convert that to delta H, so we're going to have to get that in terms of joules per mole. So remember, this came from 1.25 grams of the ammonium nitrate. So for 1.25 grams, we can convert that to moles by multiplying by the molar mass. 1.25 grams of ammonium nitrate times 1 mole per 80.1 grams gives us this many moles of ammonium nitrate. Well, if we want to look at the delta H for this, the delta H was the negative 410 joules, or negative 0.41 kilojoules, for 0.0516 moles, or minus, I forgot my equal sign, minus 26 kilojoules per mole for the surroundings, for the water that our stuff was dissolved in. The temperature, the heat change of the reaction, the delta H of the reaction, is always the opposite of the surroundings. So if we measured and calculated minus 26 kilojoules per mole for the surroundings, the delta H of the reaction is plus 26 kilojoules per mole.